Alright, in this video we're going to cover complex numbers, and that's section 1.5 in the book. And what we're going to learn in this section is to use the imaginary unit I to write complex numbers, and we'll add, subtract, multiply those complex numbers, and use complex conjugates to write the quotient of two complex numbers in standard form. And we will find complex solutions to quadratic equations. Alright, first let's talk about what is this imaginary unit I. So in the previous section you learned that some quadratic equations have no real solutions. For instance, the quadratic equation x squared plus 1 is equal to 0 has no real solutions because there is no real number x that can be squared to produce negative 1. To overcome this deficiency, mathematicians created an expanded system of numbers using the imaginary unit I. And we define it as follows. I is just equal to the square root of that negative 1 number. So, and if we square both sides of this, I squared would equal negative 1. By adding real numbers to the real multiples of this imaginary unit, the set of complex numbers is obtained. Each complex number can be written in standard form of a plus b times the imaginary unit. You know, a is just some number, plus or minus, b is just some other number, and then this is the imaginary component. And where did I leave off? For instance, the standard form of the complex number negative 5 plus the square root of negative 9 is negative 5 plus 3i. Because, you know, we can take that negative 9 under the radical and change that into 3 squared times negative 1. And then we know we can bring out the 3. 9 square rooted would be 3, and that square root of negative 1 turns into the imaginary component, or imaginary unit I. In the standard form a plus bi, the real number is called the real part of the complex number. So altogether, a plus b times I, this is called the real component because it's just a number. And then you'll have plus or minus. This will be the imaginary part. Imaginary part. So the real component, this is just a number, and then here we have some number times I. Altogether, that is a complex number. And here's our definition in the blue box. If a and b are real numbers, then number a plus b times I is a complex number. And it's said to be written in standard form. If b is equal to 0, the number a plus b times I is equal to a. And it's a real number. If b does not equal 0, the number a plus bi is called an imaginary number. A number in the form of b times I, where b is 0, or not equal to 0, excuse me, is called a pure imaginary number. There is no real component to it at all. So the set of real numbers is a subset of the complex numbers. Remember in chapter P, section 1, you know, we came up with the real numbers, and we had, you know, there was a flow chart where we came up with the different pieces to the real numbers. Now if we take those real numbers and merge them up with those imaginary numbers, and we put them together, we get our complex numbers. We have a little theorem here. When are two complex numbers equal, two complex numbers, a plus bi, and c plus d times I, written in standard form, are equal to each other, a plus bi is equal to c plus di, if and only if a is equal to c. So this number here, a and c, are exactly the same, and b is equal to d. So the imaginary piece, b times I, is equal to d times I. If those are equal, then the overall, the complex numbers, are also equal. Okay, let's back up here a little bit. Yeah, back to this. You know, we should know these imaginary numbers up to the 4th power. So we're going to come up with, well, we know what I is, and we're going to find I squared. Make that a little smaller. I squared, I to the 3rd, I to the 4th. So we know by definition, I is the square root of negative 1. Square root negative 1. If we square this side, we get I squared. If we square this over here, we're going to get negative 1. So what would I to the third be? Well, remember, we can break I to the third up into I squared times I. So if we multiply these together, we're going to get negative I. Or, we wouldn't want to multiply the negative square root of 1 by negative 1. We're sort of multiplying here. I times negative 1, because this is the same thing as I to the first power times I squared is equal to I to the third. So negative I. And then I to the fourth power. If we square I squared, we get I to the fourth. So if we square this negative 1, we'll get its value. Negative 1 times negative 1 is positive 1. And from here, they're just going to repeat. We have our I to the first, second, third, and fourth. These are also equal to I to the fifth, I to the sixth, I to the seventh, I to the eighth. And then they repeat again. I to the ninth, I to the 10th, I to the 11th, I to the 12th. And, you can see the pattern. So we can actually evaluate I to any exponent based on these patterns. There we go. All right, let's do a couple easy problems here. Operations with complex numbers. And in example 1, we're just going to add and subtract complex numbers. So here, we're adding. We can just ignore the parentheses and say the real piece plus the real piece. 4 plus 1 is 5. And then we have plus 7i and a minus 6i. So that would be a plus 1i, or just plus I. In the next one, now we just got to worry. We do have a negative sign and our parentheses. We are going to distribute that negative sign first. So we have I plus 1 plus 2 times I. Distribute the negative, minus 4. Distribute the negative again, minus 2i. And now that the parentheses are gone, we can just collect up our like terms. So let's look at the real pieces. 1 and minus 4 is negative 3. And then we have 2i and negative 2i. So that would be plus or minus 0i. And we could just write that as negative 3. Now, on part C here, they just kick it up a notch and they give us 2 negatives that we have to distribute. So this 3i stays the same. Distribute this negative. Negative times negative 2 is plus 2. Negative times 3i is minus 3i. And then we have this negative to distribute. So that is going to be a minus 2 and a minus 5i. So let's collect up first all the real pieces. Plus 2 and minus 2. So that would be, to write it in standard form, 0. We got to show there is a 0 in the real component of this complex number. And I don't know if I need a plus yet. 3i minus 3i, those cancel out. So we're just left with minus 5i. 0 minus 5i, or just negative 5i. And we got one more to go here in letter D. You see, these are a lot like adding and subtracting polynomials. Just really, watch your minus signs when you're subtracting. So we're going to have our 3 plus 2i, and then a plus 4 minus i. And here we distribute the negative, so that's going to be a minus 7 minus 1i. And no, we'll just leave it like that. So collect up the real pieces. 3 plus 4 is 7. Minus 7 is nothing, so we're going to have a 0. And then we have a 2i minus 1i minus another I would be 0, plus 0i. And if the directions specifically said, write it in standard form. Remember, standard form is the real piece plus or minus the imaginary piece. So 0 plus 0i is in perfect standard form. Next, we're going to multiply, and you're probably going to figure out how this goes. In the first one, nice and easy, we just distribute the 4. 4 times negative 2 is negative 8. 4 times 3i is plus 12i. Aha! Now when we get to foiling this out, multiplying out the binomial, you're going to see something happens here. So I'm going to move this one up. First times first is 8, and then plus 6i is the outers, minus 4i the inners, and then here, negative I times 3i. So that's going to be minus 3i squared. And we don't have to leave, we should not leave that I squared there, because what is I squared equal to? Remember, we did our little, the first 4 powers of I squared is negative 1. So we can replace this I squared, that's going to be minus 3 times negative 1. So this I squared, it's sort of just going to hop over here and change this sign. Right here this is a minus, and now we have minus 3 times minus 1 is a plus 3. So you can think about it, this I squared is going to hop over, change that to a plus, and then the I squared is gone. So now we can combine it a little bit farther here. Let's see, we now have 8 plus 3 is 11, that's our real component. And then plus 6 and minus 4 would be a plus 2i. So remember that I squared, you can replace I squared with a negative 1. In effect, it's just going to change the sign of that last coefficient. Let's try another one here in letter C. And if you take a little time to look at the problem, 3 plus 2i times quantity 3 minus 2i, the terms are the same, but the signs are off, so this is a sum and a difference. And if we were to FOIL this out, our outers and inners would cancel. Our outers here would be minus 6i, and the inners would be plus 6i, so those are going to cancel out. So to do this, the little shortcut is just first term times first term is 9. 3 times 3 is 9. And then we're going to have a minus 2i times 2i is 4i squared. And I squared, we can replace that with a negative 1, and when we multiply the negative 1 through, it's just going to change this sign. And we all know that 9 plus 4 is 13. Aha. Now this one, it is a quantity squared. So you could write it out twice and FOIL it, and there's nothing wrong with that. You'll get the right answer if you do that properly. Or we could do the shortcut. First term squared is 9. This is a plus, so our middle term will be a plus. We multiply these two together and double it. 3 times 2 is 6i, and we double that into a 12i. And then we're going to have plus the last quantity squared. 2i times 2i is 4i squared. And the I squared is going to turn into a negative 1, which will just turn this into a minus. So let's collect up our real pieces. 9 minus 4 is 5, and then we have our plus 12i. Real component, imaginary component, all together it's a complex number. Some practice problems in the huddle. Pause the video, take these for a test drive, start the video back up, and see how you did. Alrighty, let's check out this first one here, just a simple addition. So we can ignore the parentheses and just collect our like terms. 7 plus 3 is 10. Plus I minus 4i, that's a plus 1i. Plus 1 minus 4 would be minus 3i. Next we have a little subtraction going on here, so we got to distribute that negative. It's going to be 9 minus I. Negative to 8 is negative 8. Minus to minus is plus I. And if we collect up our real pieces, 9 minus 8 is 1. And then minus I and plus I, to be complete and put it in standard form, it would be plus 0i. So adding and subtracting, not a big deal, just watch that negative when you subtract. Now we're going to multiply. Got a double of that one. So the first one, we're just going to have to FOIL it out. It's none of our special ones. So first times first is 21. The outers will be minus 35i. The inners minus 6i. And then negative times negative is positive. 2 times 5 is 10, and that's an I squared. The I squared will just change this last sign to a minus. And now the 10 is a real component. So 21 minus 10 is 11. And then we have minus 35 and minus 6 is minus 41 times the imaginary component. And one more to go. This is our binomial squared. So we could, write it again and FOIL it out. Well, let's do our little trick here. First term squared is 36. That's a plus. Multiply these together and double it. 6 times 7 is 42. Double that is 84i. And then plus 7i squared is 49i squared. And the I squared is going to change this to a minus. So we have 36 minus 49, that's negative 13, plus 84i. And the assignment that goes with this section from the book, 1-5 day 1 on your assignment sheet, page 128. Looks like a lot of problems, but they go quick, especially when you're, just adding or subtracting, some imaginary numbers. See you in the next video.